be a stable state and another will be a quasi-stable state so that you can generate an pulse width of a required duration. So whereas in case of astable mode, so both the states are quasi-stable state. There is no stable state in this case. So using n components, so you are generating n square wave at the output. Or even you can vary this with respect to the t value by designing. So a stable mode of operation is nothing but both the states are n is not stable. So I are low. So there are two states here which will vibrate from low to high or from high to low. So both the states are in unstable. So we will call it as astable multivibrator. So it is not stable. So you have to design that. So take heading as an astable multivibrator and copy down this circuit diagram. So you can see here pin number 2 is directly connected in this. So in astable mode of operation, so we will call this is it is used in a free running oscillator. So in free running oscillator, you know that oscillator is which converts DC to AC. So in free running oscillator, without giving any external input signal for an oscillating signal, so you are generating an oscillation. So from the low state to high state. So same thing here also we won't give an input signal here. Instead of that, pin number 2 is an input which is connected to the external circuit of R1, R2 as well as C. So copy down this circuit diagram. So you know that is 555 timer consists of 8 pin package. Pin number 8 is VCC, pin number 1 is ground, and pin number 2 is input, and pin number 3 is output. So pin number 4 is reset. Always it will be given to the positive VCC. So if you want to reset, if you give to the negative of the ground, the chip IC will be reset. So always for operation of astable as well as monostable multivibrator, pin number 4 will be given to an positive VCC. And pin number 5 is an control. It will control the an output voltage. So any spike which will be come into the picture. So it's come into the at the output. So this pin number 5 which is connected externally with a capacitor to the ground. So this capacitor will and suppress the noise or spikes at the and on to off and off to on stage. And pin number 5 is control. Pin number 6 is a threshold. So pin number 6 always it is given to the capacitor, so which is connected externally to the 555 timer. So that is it depends upon charge time. So the threshold will be maintained. So threshold depends upon the and capacitance which charges from 1/3 of VCC to 2/3 of VCC. And you know that is an external resistance in case of a stable multivibrator is R1, R2 as well as capacitance. So there we have used the value of R1 as well as a capacitance, only one resistance and one capacitance, which is used in case of a monostable mode of operation. In case of a stable mode of operation, so R1, R2 and capacitance is used. So you can hear the voice now. Hello, student.
Yes, ma'am.
Yes, ma'am. Thank you. So pin configuration should be written properly. So can I go for next slide? Have you copied down this? So you have to write both circuit diagram as well as internal block diagram of a 3x5 timer as an astable mode of operation. So external circuit what you are connected in astable mode of operation is R1, R2 as well as C. So the connection 6 and 2 will be short circuit and given to the capacitor, and R1, R2 which acts as a divider circuit. And pin number 7 is discharge, which is connected to a discharge transistor internally of a 555 timer. So why it is called as discharge? Because whenever transistor is in on condition, so capacitor will have a path to discharge through that. So it is called as a discharge pin. Can I go for next slide? Same thing you can copy down in here also. So copy down this 555 timer as a stable multivibrator. So always a monostable 555 timer will be explained with the help of internal block diagram and external circuit which is connected. So 555 timer, you know that it consists of two comparator, which upper comparator as well as lower comparator. So take down the circuit also. You have to write both. So same internal block diagram of a monostable or block diagram of 555 timer what you have written. So astable mode also, but only the connection what you connect externally R1, R2, C, that connection you have to check out properly. So why it is called as 555 timer? Because internally it consists of three resistance with 5 kilo ohm. So 5 kilo ohm is called as a 555 timer, 555 timer. So which acts as a divider circuit for the 555 timer. R internal resistance R as well as R. So why we call this comparator as an lower capacitor and upper capacitor? So lower capacitor which works for 1/3 of VCC and upper capacitor, upper comparator which works for 2/3 of VCC. Meanwhile, answer your own call. 1. Vaibhav Sagar. 2.
Yes, ma'am.
3. 5. 6.
Present, ma'am.
7. 6 is present. 7.
Yes, ma'am.
Yes, pa. 7. 8. 9.
Present, ma'am.
11. 12. 13. 14. 15. Bhavana. 16.
Present, ma'am.
17.
Yes, ma'am.
18. 19.
Yes, ma'am.
20. Chandrasekhar Gupta. 21. 22.
Present, ma'am.
23.
Present, ma'am.
24. 25. 26. 26. 27. 28. Ashita. Why so many absentees? If they come late, I won't give the attendance for them. 29.
Present, ma'am.
30.
Present, ma'am.
31.
Present, ma'am.
32.
Present, ma'am.
33. 34.
Yes, ma'am.
35.
Present, ma'am.
36. 37.
Yes, ma'am.
38. 39. 40.
Excuse me, ma'am. 20
Yes, sir.
present, ma'am.
Why you came late?
Ma'am, I couldn't unmute, ma'am. Network issue.
Okay. 40, 41,
Present, ma'am.
42,
Present, ma'am.
43,
Yes, ma'am.
44,
Present, ma'am.
45,
Present, ma'am.
46,
Yes, ma'am.
47,
Present, ma'am.
48,
Present, ma'am.
49, 49, 50,
Present, ma'am.
51,
Present, ma'am.
105,
Present, ma'am.
106, Dhanush, 107.
Present, ma'am.
Okay. So can I go for next slide?
Excuse me, ma'am.
Yeah, tell me for 1
Ma'am,
minute.
it's late.
I'll come for the attendance. Can I go for next slide? All of you copy down this? Or you want time for this to copy? So take down this waveform. 400.
Ma'am, 107 present, ma'am.
Not 7 present. Okay. 400.
400 present, ma'am.
401.
Present, ma'am.
402. 403.
Present, ma'am.
404.
Present, ma'am.
405.
Ma'am, excuse me.
Yeah, tell me.
402 present, ma'am.
Okay, pa. 405. 406.
Yes, ma'am.
407.
Present, ma'am.
408.
Yes, ma'am.
409.
Present, ma'am.
410. 411.
Excuse me, ma'am.
Yes, pa.
405 present, ma'am.
Okay.
Ma'am, USN 8.
Yes, and 8.
Ma'am, 13.
13. Why Ayush Kumar, you came late?
No, ma'am.
Okay. Then who else? Latecomers. So copy down this waveform. All of you mute your mic. So take down this waveform. So that is in case of an monostable multivibrator. So this charging time, it will be a discharge sharply, whereas in astable mode, it discharge at a certain time. So always T1 will be greater than T2. Charging time will be greater than discharging time. So we have copied down this. So waveform, circuit diagram, internal block diagram, and you have to for an equations. Take down this equations. T1 is 0.693 times R1 plus R2 into C. So why I've told that is, and T1 should be greater. You can see charging time, it charges through R1 plus R2. So R1 plus R2 resistance into C is multiplied with 0.9693. And R2 is 0.693 R2 into C. And T is T1 plus T2 is equal to 0.693 into R1 plus 2 R2 into C. Have you done this experiment in your lab? 555 timer, using 555 timer. Do you have in communication lab? Hello students. Have you done this 555 timer astable and monostable multivibrator? You can't leave the meeting. I'll take once again the attendance. So last I'll take once again the attendance. You can't leave the meeting class. Have you done this? Have you remember? You can hear me? Anusha? Kushal?
Yes, ma'am.
Yeah. Okay. So T2 will be less compared to T1. T2 is 0.693 R2 into C, and total time is T1 plus T2, that is 0.693 into R1 plus 2 R2 into C. And always duty cycle will be expressed in T on divided by total T on plus T off, T1 by T. Or you can write by substituting T1 and T1 plus T on. So this equation in the duty cycle, so at that time you will get a duty cycle for an astable multivibrator R1 plus R2 by R1 plus 2 R2. See, only in case of astable multivibrator you will get to find out duty cycle. In case of monostable multivibrator, we won't get T2, so no need of finding out duty cycle. Only you have to find out the pulse width. Pulse width will be exactly equal to 1.1 times RC in case of monostable multivibrator. So if they ask for 8 to 10 marks, that is, write any circuit diagram of monostable multivibrator or design an astable multivibrator. So you have to write the circuit diagram, internal block diagram, waveform, and this equations. So all of you copy down this equation. So can I go for working? You have to
Yes,
respond.
ma'am.
Yes. Thank you. So listen carefully here. An astable multivibrator 355 timer is used as an astable multivibrator. So this chip which is used to generate an clock pulse wherever you are using a clock button or a push button. So inside of that a 355 timer which is used as an astable or a free running oscillator, we will call this. So free running oscillator means it will be generating continuous waveforms. So since it is a free running oscillator, so we won't give an external signal to this astable multivibrator. Without giving an external input, we are generating an waveform. So it is called as an oscillator. And astable multivibrator means there are two states, that is which is known as on and off state. So both the state will be a quasi-stable state. So both states will not be stable. You have to design with an external circuit which is known as R1, R2 as well as C. Since we are using a T1 and T2, so we have used an external two resistance and one capacitor. It is clear. So this capacitance is used to suppress the noise or a spike which is produced at the output. So this, if you come for an internal block diagram, so internal block diagram, listen carefully. So it consists of two comparator and a divider circuit, and it has got one flip flop, and the output stage is an inverter. I told that is output stage is an inverter. If you get a 0 over here, you will get 1, or 1, you will get 0. It is clear. So that is, and also it has got one transistor which is known as a discharge transistor, which is connected to a discharge point of 355 timer which is known as pin number 7. So you can see here an input is not given, so pin number 2 is directly connected to the external capacitor. So R1, R2 and C is an external capacitor which is connected to a 355 timer IC. It is clear. So now if you come for an working of that, so as soon as VCC is given, so listen carefully. As soon as VCC is given, so what happens? Capacitors start charging. So whenever capacitors charge to 1/3 of VCC, so whenever it gets an voltage across the an capacitor to 1/3 of VCC, that is, it will be charging like this. So if the voltage reach across this, so what happens? This comparator will be in on condition. It is clear. So this comparator is in on condition in the sense. So what happens? You will get the output voltage, that is, which will be inverted amplifier. So the output what you are getting will be